Yay! What do you mean it's offline? Yay! Oh, Stream Manager. Hello! Come on! There you go. Wow, stupid terminal screen. Hello, everyone. Hello. Hello. Anyone there? No one's on? Oh, this sucks. No one's on? Can I do this? Yeah, Code Runner, you're here. Today's all about you. Hey, Matt. Hey, Matthew. Code Runner today is dedicated to you. Natural Seasons. Yep. Yeah, we are back. Um, I just realized is, hey, come on, hey, Seagull. It's been a month. Yeah, it's been a month or close to it that we're on the air. Um, yeah, it's been a month. We've been away for a long time. Um, I had a personal event to do. We had spring break. We had CTF. Yeah, we are back. If good to be back. Feels like yesterday, but it feels like forever ago. All right, you can all hear video, audio. We're good. We're good. Yeah, it didn't feel that long. I agree with Tundra. Yeah, it didn't feel that long, but yet it was. Well, at any rate, we're good to be back. It's only episode 7, which is kind of feels a bit slow. Yeah, I'll do the usual spiel. Hello, I'm Ming Chow, teaching professor at Tufts University. Um, I wanted today. The topic is gonna be related to Code Runner, code_runner. Yes, today is all about you. Today is all about code, really bad code, and what you do and what you need to do. Now, I'm gonna be surprised if we're gonna need the entire day today. Today may seem kind of boring, a little bit, but I think there's something that's gonna hit you hard, and that's gonna be a question that I pose. Um, an uncomfortable question I'm going to ask you. So, the first thing today want to talk about bad code. Really, really bad code. And where were we the last time? We were here the last time we were on Twitch. I showed you folks an example of really, really bad code. Oop, oop. And let's do this from the beginning. Now, before I open, we're going to look at not one, not two, but 3 source code examples. One JavaScript, one C, and Java. 3. However, we have already seen the Java one already. Now, we've been away for a month. So let's have a quick review here. All right? Let's have a quick review. Where are the vulnerabilities? This is okay. Kicking off where we left off the last time. Where are the vulnerabilities? Point out the vulnerabilities. We're not even running code. No running of the code. All you need to do is eyeball. No running of code. That's important to know. No running of code. Okay. Hard-coded credentials, 5-alarm fire. That is not okay. Yeah, hard-coded credentials, no bueno. That's like 5-alarm fire. That's big vulnerability. Direct execution of the query. Okay, that's also no bueno as well too. the hard-coded the query string. Yeah, so number one and number two. The number one and number two biggest vulnerabilities, 5 alarm fires, critical, hard-coded passwords, and uh, hard-coded queries, aka a la SQL injection. Okay, it's not okay. Yeah, print. So not good to import everything in SQL if you don't need everything. Printing out the exception error also really bad. So one thing I can tell from this exercise, it is, although we've been away for a month, you folks sure did pay attention. Okay? So printing the exception error what mommy said, that's no bueno as well too. Okay? So if given this on a quiz or an exam or in a job interview, you gotta say right off the bat, well, you have hard-coded credentials and you have a SQL injection, and the input was not validated. You gotta get those. Now, very important to understand what we have been doing for the last few minutes. We didn't even need to run the damn code. We didn't need to run this code. We didn't even need to compile it or anything. Just eyeball it and go. Just eyeball it and go. Eyeball it, find the vulnerability. That's it. Okay. So that's an important thing to do. So am I asking you, okay, we're eyeballing code. We can find vulnerabilities by eyeballing code, right? Yep, you can do that. Okay, do we need to do this all the time? Well, for small programs like this, yes. Okay, which gets to the point of today. Now, here's a Java example. So I'm going to ask you folks now, all right, we've seen the Java example. We've seen Twitter test.java. So now my question to you folks is this. Let's move on. Let's have a vote here. You want to go to C code or JavaScript code first? Which one? Pick. JavaScript or C? Go for it. JavaScript or C? Okay. Alright, I was going to say Kaban wins because he was the first one to respond, but it seems like we have an issue with C. Okay, let's take a look at C next. Now let me ask you folks this, before we really proceed. Before I open up the C code example, tell me where do you program, where did you use C programming in? Not C++, straight C. Where do you use C? What courses? Academic courses. Okay, you got operating system, CS40. Okay, we'll talk a little bit more about CS40 a little bit later. Okay, a systems course and different. Okay, never used it before. Okay, that's fair. Not bad, not bad, not bad. It's okay. System programming, fair enough. Are you folks ready? Are you folks ready? I'm going to open up the C code right now. On a scale of 1 to 10, by the end of today, you need to know this. This is a 10. It's a good also reminder to message there are some mistakes that you cannot make. And here, it's a C code example. I'm going to leave this up here. I'm going to leave this code up here. You tell me where the vulnerability is. And for those of you who have programming in C, this should be pretty straightforward. 21 lines of code. Doesn't matter if you didn't go to Tufts, went to Tufts, doesn't matter. Doesn't matter if you programmed in C before in some way, shape, or form, you can understand this code. Even if you have never programmed in C before, even if you haven't, you can understand by way of the function name and also comments. Where's the vulnerability? I'll give you a few minutes. You can put a line number. Where's the vulnerability? Okay, what the hell what does that mean, buffer overflow? Why? What's the root cause? Okay, I will actually say this. Is there any user input here? The answer is yes. The answer is argv. Argv is user input from the command line. So there is user input here. User input in C is an argv. What line? Why? Where is the vulnerability? Okay, so Tundra. Tundra, you wrote stir copy isn't isn't it generally unsafe? Wait a minute, wait. Back it up for a second. Okay, Code Runner says line number 16. Okay, now Tundra 9898. I'm not going to ask you what school or institution that you went to. But the way that you wrote that isn't it generally unsafe? Did you learn that in the classroom or did you not learn that in the classroom? Where did you hear that from? Where did you hear that from? Well, okay, that's fair, which you could remember. But did you learn it in school? I guess that's the question. Any chance did you learn that in school? Yeah. Who here took 40? Who here took CS 40? And did it ever talk about some of the dirtiest of the dirty functions in C you should never ever use? Okay, your guess is me. Okay. Okay, so Cabona, did they ever talk about like the dirtiest of the dirty functions you should never ever use? Come on. It's funny because you just said buffer overflow, boom, just like you got it. But I was wondering, where did you learn that from? Okay, you don't remember either. All right. So what's the problem with this program? The problem with this program is the content. Oh, Jesus. All right, mini donuts. Okay, let me do a demonstration, shall we? I'm going to do a demonstration now. Okay. So I am going to do a more bone.c here. The same code. So here's the idea. The idea of this C program is this. There are going to be two buffers, two arrays of size 8. Buffer underscore 1 and buffer underscore 2. Initially, buffer underscore 1 is going to have the string 1 in it, and buffer underscore 2 is going to have the string 2 in it. Okay? What we're going to do is we're going to print out the not only the contents of buffer underscore 2 and 1 and buffer underscore 1 respectively, but also where they are at in memory. And also, there is a simple int value equal, there's a simple integer variable called value here that's set at 5. We're not going to do a friggin' thing with this one. Okay, so this is going to stay content. It's a constant. But then what we're going to do is we're going to take all the user input from argv and we're going to shove it into buffer underscore 2 to replace the quote unquote one one string. So what I'm going to do is I'm going to do a GCC minus O, really bad, bound.c. I'm just going to do a compilation of the C program by way of the GCC compiler on Linux. There you go. Okay, there you go. So how do you run this program really bad now that has been compiled in C? You would do / really bad. And now I'm just going to run the just to prove to you, do a file, really bad. And it's a binary. Okay, it's a.out. But instead of a.out, I renamed it to something else. Okay? So if I do gcc bone.c, it's going to create an a.out. Okay? If I do a diff of a.out and really bad, they're the same. Okay? So now you know. But now I'm going to run really bad. No user input. I'm going to hit the enter key. And what's going to happen is it should crash because it's expecting user input. Okay? Because it's shoving user input, empty user, like a not undefined user input into buffer underscore 2. So this ain't going to work. Okay? Really bad A. Now I'm going to do user input as a character string A. Now, here you go. So now you have buffer underscore 2 is going to have contain the string 2. Buffer underscore 1 is going to have the string 1. Okay, that's fine. Now I'm going to copy 1 byte into buffer underscore 2. Alright, so far everything looks good, everything looks good, everything looks good. I'm going to add 2 ways now. Okay, everything looks good, everything looks good, everything looks good, everything looks good, fine, okay, that looks good. 3 A's. Okay, everything looks good so far. Okay, I'm going to speed this up, I'm going to do 5 A's. Alright, everything looks good so far, nothing bad, nothing bad. 6 A's. Okay, 7 A's. So far, so good. Because remember, buffer underscore 2 and buffer underscore 1 are, they're of size 8. What will happen when I actually do 8 A's now? If I do 8 A's, watch what's going to happen to buffer underscore 2 and buffer underscore 1. Uh-oh. Another A. Uh-oh. 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 Oh dear. Uh-oh. 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 And now you see the more A's that I type in, it's going to overflow into buffer underscore 1. And also, it's going to totally f up the integer value, the integer variable value. But eventually, you can crash the program. Bang, there you are. And that, my friends, is your demonstration of buffer overflow. This is not good. Now, just want to do a quick review here. I'm going to go to my web browser. I'm going to go to my web browser here. And I am actually going to go and recall the idea of buffer overflow. What is this buffer overflow thing? Okay, go to 2024 top 25 list. Alright, out of bounds write, out of bounds read. Buffer overflow, let's go to CWE 787. The product writes data past the end or before the beginning of an intended buffer. Otherwise used to describe the consequences of writing to memory outside the bounds of a buffer or to memory other than that is valid. Okay? And here it is. And it goes to other names such as buffer, it's really called buffer overflow. Okay? Why is buffer overflow a thing? Well, the reason why buffer overflow is a thing is because Here in this program, you have two buffers, two character arrays, buffer underscore 1 and buffer underscore 2, size of 8. The crux of the matter. Okay. Mommy umami. Hold on, I'll get to you in a few seconds. Here's a caveat. Are you ready? Well, actually, I can answer your question now. So, is it added A's to the other spot? You got it. How does the values get messed up again? I thought it was hard-coded. The values are hard-coded, yes. But remember, how long is the how many characters can buffer how many characters, what's the length of buffer underscore 1 and buffer underscore 2? I repeat, what is there a size, a character limit to buffer underscore 1 and buffer underscore 2? Yes, it's character 8, but it goes indexed from 0 to 7. So any of the remaining values, so if I showed you here, if I go all the way back up, where was a normal? Here, this is where things went horribly wrong, when I had 1, 2, 3, 4, 5, 6, 7, 8 A's. 8 A's, and then what happened is buffer underscore 2 has 8 A's, buffer underscore 1 contains a space. It got overwritten. And that is the whole point of buffer overflow. If however, you're trying to shove more content into a container, if you're trying to shove, okay, let me say it in plain English. If you're shoving more content into a container that the container holds, that extra content needs to go to somewhere, right? Well, on buffer overflow, that extra content get overflow and pollutes and damages the other containers. In this case, it's going to be buffer underscore 1 or characters. All that extra stuff has to go somewhere, you know. All the extra content needs to go to other variables or other places in memory. In this case, as you can see, you know, all the A's that I put in, it not only corrupted buffer underscore 1, but also value. But wait a minute, it doesn't get to the crux of the matter. It doesn't get to the crux of the matter. Why does that happen in the C programming language? And ultimately, why is strcpy so bad? The reason is this. The answer is very simple. And I'll say this right now. It's a simple thing that you can all understand. The C programming language does not use any bounds checking. I repeat, there is no such thing as bounds checking in the C programming language. I'll give you what someone actually said to me about the C programming language is, the C programming language is like a knife. You better not cut yourself with it. You can do a lot of things, but you can also cut yourself with it. And in fact, it's very easy to cut yourself using C. Yes, when C was developed and designed, it had no security in mind. So here's the thing. I now want to introduce to you the idea of the dirtiest of the dirty C functions. The dirtiest of the dirty C function. I gotta go find it. Bing! You're like this. Here you go. The dirtiest. Oh, hold on, Tundra. Hold on. It gets better than that. There you go, Tundra. Most of the vulnerabilities in C are related to buffer overflows and string manipulation. So what do they have? A buffer overflow, and so buffer overflow in programming information security is anomaly when a program writes data to a buffer beyond the buffer's allocated memory. And in the vuln.c program is 8. Overwriting adjacent memory location. There you go. All right. And so for Tundra, now this page, I just showed you, it's going to be a list of all the dirtiest of the dirty C functions. In most cases, this would actually result in a segmentation fault, but especially, here it is, specifically crafted malicious input values adapted to the architecture and environment could yield to arbitrary code execution. Okay? Gets. Here you go, Tundra. The standard I/O function gets does not check for a buffer length and always results in a vulnerability. Mitigation. Prefer to use fgets and dynamically allocated memory. Aha, a friend stir copy. The stir copy for built-in function does not check buffer length and may very well overwrite memory zone contiguous to the intended destination. In fact, the whole family of functions, stir copy, stir compare, stir cat, you folks used this before. If you've taken CS40, the architecture class, you probably have used one of these functions. All bad, all vulnerable, okay? All bad, no bounds checking, no nothing. Your mitigation, okay, the best way to mitigate this use is to use stir L copy or an equivalent, that if readily available, that actually have bounds checking, okay? Another and slightly less convenient way is to use stern copy, which prevents buffer overflow, does not guarantee null termination, okay? Furthermore, if you ever do a Microsoft search for stir copy, you'll notice something very interesting. Here it is. Stir copy from Microsoft Learn. Stir, the documentation, C, C++ assembly on stir copy. Here it is, but notice what will happen near the end. Oh, they don't have it. Okay, they don't have a warning here. Yeah. Here it is. They have it. They should have bolded this shit. Copies a string. More secure versions of these functions are available. See stir copy.s underscore s. And here it is. Copies of string. Here it is. Copies a string. These versions of stir copy, WCS copy, and MBS copy have security enhancements described in security features. Okay. Do we still see people that actually use stir copy without any bounds checking? And the answer is absolutely, because people don't even know any better. Okay. And you notice that whether it's stir copy with an S or an L, they always have an extra parameter that actually where you have to specify the length, destination, size. So, for example, for stir LFS, PS vulnerable code. Yeah, here it is. Stir L copy, destination, source, some number of buffer size. Now, I have a friend and a security luminary that also goes slightly better. Now, this is going to actually cause a flame war of some sort, or people flinging feces at each other, which is this. A draconian way to resolve the buffer overflow problem is to don't program in C and C++, use Java. This, my friend, was my old mentor, and he was like, this is why you should use Java, because in Java, the programming language, there is bounds checking. You can also say the same thing about Rust. But unfortunately, if you want to something that is close to optimal performance, you always use C. sprintf, okay? Just like the previous version function, sprintf does not check for buffer boundaries and is vulnerable to buffer overflows. printf inference. Other vulnerabilities in this category are concerned with string formatting attacks. Okay, cause information leakage, overwriting memory, yada yada. Okay, I'll give you this. But so printf and friends are also vulnerable to string formatting attacks as well too. But the big one, I got to get the point across is a lot of the C functions, no bound checking, and that is why vulnerabilities such as buffer overflow happen. Yeah. So these are some of the dirtiest of the dirty C functions you should never use. And then just what I showed here, this shows you what happens if you actually try to write too much data into a container or an array that has a certain size. All that extra stuff needs to go somewhere, right? And is buffer overflow still a problem these days? Yes. It's a lot harder to exploit too. That's why I don't get into the exploitation of buffer overflow. If I taught this course in 2005, totally different story. Actually, another thing that is for your interest is, does the compiler warn you about compiling a bad program? The answer is it depends. If I did GCC here, vuln.c, I got no errors. I didn't even put in any error flag. It just compiled as it is. On Mac OS, if you try to compile vuln.c, it will give you like, it'll be no. We see that you're using strcpy here, so we're gonna actually put something called stack guard in, so you actually don't overwrite memory. The compiler, yeah, exactly. It's the compiler loves you or the compiler hate you. It depends. Okay? So that is really, really bad code example number 2. So we're down to 1 now. We've seen really bad code in C, really bad code in Java. And also now we're going to look at JavaScript. What the heck is that going to look like? You ready? For all you JavaScript buffs out there. Short code, 18 lines, where's the vulnerability? Where is the vulnerability? Only need to print out one line. One line. Seagull Lover by the Bay, line 12. Seems like you caught that one right away. How did you know that? Who taught you that? Who taught you that? It's directly evaluate the data that you taught. I did? I taught you that already? Anyway. Yeah, the issue is eval. But did I ever tell you the real statement, though? I don't think I told you this. Eval is evil. Eval is evil. So let's have an understanding what is eval. Okay. Let's go to the Mozilla documentation on eval. Now, there you go. Okay. In every single programming language out there, every single programming language, C, C++, Python, Ruby, JavaScript, whatever, they all have an eval function. The whole idea of eval actually is very simple to understand. It takes in one argument, which is a string. All right, your input is a string, your output is the evaluation of the string as code. I repeat, eval takes in a string and then evaluates it as code. So here's a good example. Console eval 2 plus the string 2 plus 2, the output is going to be 4. That's what it is. Okay? Now, the idea is very simple to understand. it can be abused really easily as well. And notice the warning in eval. Executing JavaScript from a string is an enormous security risk. It is far too easy for a bad actor to run arbitrary code when you use eval. Never use direct eval. Using direct eval suffers from multiple problems. Executes the code as passed in as privilege of the caller. Eval is slow. Yada. Yeah. Okay. Where is he? Like people use eval. Yeah, it's based on either laziness or unless you really have to, unless you really know what you're doing, but good luck with that. I know that the library to parse JSON actually uses eval. Eval is evil. Okay? DigitalOcean, why you should never use eval. The eval function has been around for a long time in JavaScript. You usually don't see it anymore. Okay? I'm going to send you all this. And again, a friendly reminder is that eval is used in every single language. The malicious code, terribly slow. Okay? There are a small subset of JavaScript development that uses eval. Anything if you're doing command line, module system, interpreters, compilers, that may be a good reason to use eval. But you gotta really tread carefully. So you maybe wonder, eval keyboard, there's a whole bunch of literature on this. Okay? But yeah, it's one of those things that unless you really know what you're doing, good luck with that. Yeah, don't do it. So let's go back to this example. Why is eval actually so dangerous? So what this program is, it just runs a web server of some sort. So I'm gonna run this. What's my IP address on this damn server? I'm 218. Okay. So I'm going to run node.js server.js and the server is on. I'm also going to fire up another terminal here. I'm going to fire up another terminal. Curl minus data. I'm going to post data. I'm going to type Tundra. IP address : 3000. Yep. I got some data, Tundra, and end. So how it does is it just listens to an HTTP post request. Sends an HTTP post request. If it gets data, prints it out on the screen, there you go. Alright. And then somehow it also evaluates the data. Okay. Okay. See how that works. Alright, I'm gonna hit Control C. I'm gonna do this again. Seagull Lover. I'm gonna send Seagull Lover to 192.168.1.218 at port 3000. This program is running at 3000, right? Yep, 3000. And I got some data, Seagull Lover, and end. But what happened instead, if I actually send in a string that is like console.log hi, semicolon, which is like a print statement. Look what happens. Oop. Console.log hi. Okay, that didn't work. But do I need the semicolon? Ooh. Hi. And it evaluated a console.log statement. Hello, world. Yeah. It evaluated console.log hello world. Not bad. Okay. What happened if I do 9 plus 8? Hey. Now if I do console.log 9 plus 8, 17. Not bad. See a way I can kill the server? What happened if I do console? Ooh, I got a good one. Console.log request. The request object. Bing! Look at that. That is a request object in JavaScript in Node.js. Okay, the server's still running. Can I kill it? For a program like this, what is the point of using eval? Or is this just, oh, that's a good question. It's just for a demo. This is why eval is not good. I'm showing you how you actually can, how eval can actually execute anything that you want as a string as code. Yeah, this is why eval is so dangerous. You feed in user input, that is a user input, by the way, is always a string. Always a string. You feed it in to the eval function, gets executed. How about this? Console.log, and I do process.exit. I think this is gonna work. I haven't done this for like forever. I didn't even prep for this today. Honestly, I did not prep for this today. Process.exit is to kill any, like to kill the program. Does this shit work? Oh yeah! Boom. Yeah. Now that shows you eval is evil. Okay? The answer to the thing is eval is evil. Okay, that's the moral of the story. Eval is bad. So is in stir copy. So is in stir copy. So where am I getting at this? So far you've seen 3 code examples. 3 examples. We did run the JavaScript and the C example. We did. But could you pinpoint the vulnerabilities by just eyeballing the code? Absolutely. You did that for all 3. Before, even if I didn't run any of this code, okay, even if I didn't run any of those 3 examples here, I didn't need to run this. I also didn't even need to, what the fuck? I didn't even need to run this. And you all pinpointed the I didn't even run the Java example. You all pinpointed the vulnerabilities just like that. That's great if the program is 10 to 20 lines of code, but it's not so great when you're dealing with hundreds of thousands of lines of code, and including things like, let's say modules, okay? So where am I getting at here? What I'm getting at is the idea is, look it. You can find vulnerabilities in source code without even running it. And that's important to do. You can also find vulnerabilities by running code. That's another thing as well. We'll talk, but that's the lesser of the important thing. Yes, you can eyeball code and find vulnerabilities. But if there's so much code, you can actually have the same idea as well. It's just you don't use your eyeballs. You do something called static analysis, or better known as code scanning. And that is the real gist of today. You've seen really, really bad code. Okay? You've seen really, really, really bad code. I'll fucking this file. Okay? But now, I'm going to add a tool to your arsenal. If you like to program and stuff, you got to know this. You got to do this. It's called static analysis. Bing! Static analysis. What is it? The real thing is here. Here's the thing about static analysis. Code scanning. That's what it is. However, there's one couple of very important points. The key point. Absolutely no program execution. None. Code scanning, the key point. Static analysis, no program execution, no code execution at all. Don't need to compile anything, nothing. No running a program, no A-dot, no compiling into A-dot out, no running of A-dot out, none of that. Okay? The pros. Also the cons. Here are the pros. Okay? Doesn't matter how big your code base is, 100% code coverage. Even dead code or sections of code that cannot be reached while execution, you're gonna find that. This is the big thing. 100% code coverage. It's going to look at every single line of code. So if you feed in a code base that is 1,000,000 lines of code, it's going to look at all 1,000,000 lines of code. However, there's some bad things as well, too. Here's the bad news. The bad news about static analysis, okay, can generate a ton of false positives. This is the biggest problem with using static analysis tools. You use static analysis tool, it's just going to say, oh, the skies are falling for every single line. Or it actually even bring back error messages about syntax, and you don't give a shit about those. The other problem of a static analysis tools is it can't find configuration or runtime issues. That's like, duh, because there's no way running a program. Okay? So, examples of static analysis tools. Anyone ever heard of something called grep? You can write your own static analysis. You can write your own static analysis tool to find vulnerabilities in C program. The dumbest one that you can do is just create like a word list. Just use a word that create like a word list of all the dirty function, C function like stir copy, and just like run through like every single like C source code and see if it has like any of those words. So it's like a blacklist, and it works. That's a static analysis. That's a static analysis tool right there. But that's kind of hokey. You can use grep. Have anyone ever heard of something called lint? Have anyone ever heard of something called lint before? Lint is the quintessential static analysis tool. Lint is the tool that I think for years it was built into like every compiler or something. Like every programming language has what is called a linting tool. It's just going to find, like a linting tool is going to find all the problems. In fact, I'll show one to you right now. I'm going to take the JavaScript example. That was my bane of my. That was a bane of my. I appreciate it. Yeah, lint. Let me show you lint. JSLint. JSLint. There it is. JavaScript Static Analysis Code Tool. The Wikipedia entered JavaScript JSLint is a static code analysis tool used in software development for checking if JavaScript source code compiles with coding rules. Okay, that's good. Static analysis tool. Static program analysis is the analysis of a computer program performed without executing them. In contrast with what I'm going to talk about later. Okay, dynamic. That's the least important one. So I'm going to go to jslint.com. How you use JSLint is very simple. Paste in your JavaScript code. Ooh. No, I'm not going to use no. What's fart? Did I say never trust a... Ooh, never trust a fart? I don't know what these are. And then all you have to paste the code, hit JSLint, and bang. And not every single line of code becomes like, oh. Yeah, that's lint. And as you can see, I'm so sorry, Tundra. This is the yeah, there are plugins. There are plenty of plugins. I'm so sorry, Tundra, if this brings back painful memories. I'm so sorry. Lots of false positives. I'm so sorry. Sorry, man. Sorry. Okay. Barcode. And this is a big one that a lot of people like now is Snyk. SNYK. Okay. Veracode and Sneak are both commercial products. However, they're pretty damn good. I'll show you. Yeah, thanks for the condolences, but I'll show you. Oh shit. I'll show you a Veracode report. Hang on. Veracode static analysis. My friend founded the company Veracode. Products. SAST, static analysis tool. Find and fix as you code as you. Yeah, here it is. Veracode static analysis. For accuracy and seamless integration, detecting problems become expensive vulnerabilities. Find flaws, false positives. Yeah. Proactively mitigate risk. I want to give a shout out to my friends at Veracode. Chris Wysoppo's a friend. Even as you can see from the screenshot, even naturally brings back the CWEs. I'll show you what a Veracode. Oh shit! I have to open it up in DuckDuckGo because in Brave because fucking DuckDuckGo does not allow you to open files. See if I can find it. Here we go. Here is a former student's Veracode report. Yeah, Veracode report. Damn it. Actually, they gave a few guest speakers. Gave a guest talk back in the good old days. What the hell is it? Bing! Application security report. This was done on April 5th of 2000. Hey, look at that! Look at that! April 5th of 2018. Shit! Almost 7 years ago. Holy shit! 7 years ago. To the day, almost. Executive summary. And this was, I want to give a shout out to my former student, Taddy Doyle. She wrote a program on a Facebook follower counter bot in Python. Static analysis scan can say summary of flaws by severity. High, very high, low. Oh, and that's another huge problem. Yep, here it is. Scope of the scan. Code injection. Okay, so here's what the static analysis tool return. Code injection, cross-site scripting, cryptographic issue, directory traversal, server configuration. Code injection. Okay. Two of them. CWE ID, the CWE's ID. CWE 95. It will tell you the line of code where the vulnerability is found, but it can't prove. Yeah, so that's another problem. Another big problem is can find potential vulnerabilities, but cannot prove. Like, it's not going to do the pen testing or break-in for you. Okay, so again, this kind of ties in with the false positive. Okay, so it'll show you what line number the vulnerability is found in. It'll show you what line number, let's say, for example, a strcpy is used, but it can't prove that there's a vulnerability. So the way that static analysis tool kind of work is, oh, I see values, oh, I see strcpy being used, that's bad. It doesn't prove. It just tells you, we found a thing, it's bad. Go away. That's how static analysis works. It's a good report. You go to the course website, go to CS116. There's a couple of articles I posted, a couple of readings, which if you want, yeah, how static analysis tools are used at Google and at GitHub. There are two really good articles here. It shows you the pros and cons. Friend and co-founder of Veracode, Chris Wysoppo, gave this presentation to my security class back in 2012. Okay, static analysis. Analysis of software performed without actually executing the program. Full coverage, you already know that. you can also do static analysis on a binary, like an exe file, because what it does is just reverse engineers it into code. Okay. Impossible to identify vulnerability based on system configuration that only exists in a deployment environment. Okay. Benefits of static analysis here: detect flaws in third-party libraries. You know, binary static analysis also has 100% code coverage. So if you're uploading a piece of, let's say for example, yeah, you can upload Windows, the entire Fortnite.exe or GTA.exe into a static analyzer and find the vulnerabilities. Okay, so I don't need to get into this. There are also a lot of other static analysis tools out there. I got a whole bunch of them to show. Bookmarks, computing. Ooh. There is one. Oh yeah. Shit. I'm an idiot. How many of you are in CS 105, the programming languages course? Oh. Oh. Who's in 105? Who took 105, the programming languages course at Tufts? Oh. Who took the CS 105 course here? Who's taking it now? Do they still do it? My question is, do they do the type checker? Yeah, the type checker. That's an example of that's a really good example of a static analysis tool. Now, here's why type checking is really important. Because if you get the wrong type, it could lead to some serious vulnerabilities or a program completely crashing. Type checking. So, anyone ever used Google Maps before? The Google Maps API? What, is this what people use game to try to cheat, arbitrate? Yeah, they kind of do that as well too. Okay, Capone. Okay, you do type checking and type in. Okay, that's good to hear. That's really, really good to hear. So here's a great example. If you ever use Google Maps, if you ever try to write a Google Maps on a web page, you plot a lot of points. Like, what's a geolocation? Latitude, longitude. Okay, latitude is negative 90 degrees to 90 degrees, and longitude is negative 180 degrees to 180 degrees. So, geopoints. You feed on a whole bunch of geopoints to the Google Maps API. But what is the type? What is the data type for latitude and longitude? What's the data type for latitude and longitude in a geolocation? I think you know where we're going with this. Float. Float, double, doesn't matter. Floating point, yes, a floating point. Now, the problem is user input on a web page, or usually user input, is always strings. And the Google Maps API documentation says that latitude and longitude must be floating point numbers. If you try to put strings as latitude or longitude, your map will crash. And when I taught web programming and engineering, that was the number one problem I saw all the time, because people took user input, did not convert it into a float, then try to put the latitude and longitude as strings into a geopoint, bang. Map never works, okay? That's why type checking is so important. Okay, in this example of latitude and longitude, they gotta be floating point numbers. But if you use something other than floating point numbers, the map isn't going to work. That's why types are so important. Okay. Meta built something called Flow. Free open source. Flow.org, static type checker for JavaScript. Okay. Another one. There's so many of these, so many. That's another problem. Is there's so many static analysis tools. Uh, anyone ever want to have a job at Stripe or Shopify? They use Ruby. Stripe and Shopify both use Ruby. Ruby, Python, they don't have type checking. Well, they do have type check. They don't. I mean, you can go write a Python program, a Ruby program without specifying any types at all. JavaScript as well. Uh, anyone programming Objective C still or Java? What the hell is it? Infer. There it is. Infer by Meta is a tool to detect bugs in Java, C, C++, Objective-C before it ships. Gives you insights on Java, C, Objective-C code before it ships with bugs. There's a video here. And one more I will show is GitHub. GitHub now has code scanning to find vulnerabilities. Things have gotten so bad that now you can enable code scanning in GitHub repositories. There it is. Okay, you have to, okay. You can also integrate third-party tools. So, static analysis should be added to your toolchain when you do any sort of programming or development. Okay. I'll come back to that. Oh, the one tool that a lot of people like is Snyk. Developers get SNYK. Ooh. AI-powered developer platform. Okay. The products. Hey. Hey! What the hell? Oh, keep fucking resetting all the time. God. Here it is. DuckDuckGo got more problems than I thought. Snyk code. Yep, static application security testing tool. Yep. There it is. It is, I've heard it is pretty nice. Okay, it can identify things like here it is, cross-site scripting, right on the code. Does that use as Copilot? I want to come back to that a little bit later. SQL injection, here it is. Extensive code coverage. I want to come back. Natural seasons, does that use Copilot? I'm not sure. But you raise up a very interesting point that I do plan to do in a few moments. Integration. Give it a try. Now, give Snyk a try. Give a static analysis tool a try. Here I'm going to tell you right now, on the air, is you are forced, like the next lab in the course, in this class, which is the technical risk analysis. Here's the key point. If doing a technical risk analysis, what it really is this. You are actually forced to actually review the source code. I'm not asking for much here. I'll give you that. I'm not asking for much, but I am asking you that you take a look at the source code. Ideally, what would be really nice is that you use a static analysis tool. Like, I give you the entire source code here and send it to a static analysis tool of your choice, like Snyk. And I'm giving you a 0.1 extra credit for this lab if you use, look at, I'm giving you a 0.1 bonus. It's not much, static analysis extra credit, so you run a static analysis tool on the CTF game file that we just played. The reason why I'm giving you a 0.1 bonus is so you get into the habit of using static analysis tool. Yeah, I know for Tundra this brings back horrible memories, but still, it's better than fucking nothing. Okay? It's better than nothing. You should really get into the habit of using static analysis tools for all the development work that you do. Oh, that's a great question, Flex. And it comes with a lot of examples. How should we limit the number of examples? You have one or two options. Number one option is if you want to go overbearing and just list everything out. Number two is just pick the important ones. That's a great question, though. That's a really good question. Ideally, put the most important ones. I'll give you this one on the air since if you're here. I mean, you know that SQL injection gotta be one of those big ones. Okay? Here's the thing. Yeah, you can get overwhelming and list everything, but just pick the important ones, the critical ones. The 5-alarm, 4-alarm fires. Okay? Now, in the interest of time, so now I think I make it pretty clear what static analysis is, but what's the opposite? Dynamic analysis. Holy shit, again, I always say we're not gonna use all the time, but we are. Okay, dynamic analysis, you probably figured what this is, runtime, execution of code. Okay, the pros, the cons, the example. The pros. Can find configuration issues. Now, the con. This one is crystal clear. There's no 100. This one, unlike static analysis, no 100% code coverage. So the difference between dynamic analysis and static analysis is static analysis, no code execution. Just look at the code, eyeball the code, scan the code. Dynamic analysis, need to run the code, need to execute the code. And there's a big problem is that, well, static analysis will actually do 100% code coverage, whilst dynamic analysis, not 100% code coverage. What about real world example? There's one. What is the quintessential dynamic analysis tool? Should ring a bell, right? Just very quickly. Probably, arguably, the most famous dynamic analysis tool. Which one? What is it? Don't tell me you have not used it. I hope they still use this in 15 and 40 at the very least. No, not IntelliSense, no. Again, I hope they still use this in the CS15, the data structure, and the architecture course. The most famous dynamic analysis tool of them all. Oh, really? You guys don't know what I'm talking. No, not GDB. Well, no. The most famous dynamic analysis tool that actually requires you to run the code. There you go. Valgrind. Yes, Valgrind is the instrumentation framework building dynamic analysis tool. The most famous dynamic analysis tool of them all, Valgrind. Let me ask you, do they still use Valgrind in 15 and 40? They still use Valgrind in 15 and 40? Okay. You know whose idea it was to use Valgrind in CS15 data structures? You know who it was that required the use of Valgrind in data structures? The other question is, who's the one that started it all? Does anyone know who started it all? Who required Valgrind? Who's the first one to do it? Anyone? Take a guess. Drop names. Okay. So it was Norman Ramsey who designed CS40 the way it is today. And he was the one that required Valgrind. It was me who stole that idea, adopted Norman's idea, and used data structure, Valgrind and data structures for CS15. Yes, believe it or not, I taught data structures for 2 years in 2011 to 2013. We had a great time. No one died. We had fun. They kicked me out after 2 years because they wanted someone more with a theory push. And that's fair. So that's that. So there's a little history for you about the use of Valgrind. So wait a minute. There's one conversation. There's one topic here. But what about AI? What about you using ChatGPT? What about using LLMs? Is that static analysis or dynamic analysis? The answer to your question is this. There's a great question. The answer is TBD. Now, what do I mean by that? I don't have a running version of ChatGPT, but I do have a local LLM. So I'll use localhost 3000. I use Ollama. So the thing is that we're not 100% sure where ChatGPT and Claude really fit. On surface, it looks like ChatGPT looks like static analysis tool, but we cannot be so sure if it's doing any sort of execution under the hood. So here, can you find the vulnerability in the TAT C code? Okay, execute. Ooh, that's not. That looks like that execute code for analysis. I'm gonna try this next, but that's dynamic analysis. But I'm gonna upload a file, and I'm gonna use Llama 3.1. I'm going to use old. I'm going to use bad code. I'm going to upload vuln.c. Let's see how it does. Can you find the vulnerabilities in the attached C code? I'm going to send a message and let's see how it does. I haven't tried. Ooh, this. Hey! Yeah! Hey, using LLM for this stuff looks great. Hey, see kids? I'm not lying. Not bad, not bad. Okay, what if we did this? If we actually do this again? Not the C code, but the Java code. And also, you are strongly encouraged to do this from now on. You'll have my permission to use AI and LLMs to analyze code for vulnerabilities. Really good use. Yeah, here you go. Here you go. SQL. All right. I like where this is going. This is SQL injection. All right. This is looking good. Looking good. Oh, yeah. Oh, this is wonderful. Okay, so LLM. It actually Yeah, I found the number 1 and number 2 vulnerability. Hard coding of sensitive. Yeah, that's no good. Did a really good job with that. How about this one? Yeah, I'm running it locally. Llamas, yes. I don't trust OpenAI. How about this? Hey, what's taking so long? There you go. I did not even try this. I did not train this. I did not train this model on my. Yeah, just on my Mac. Just on my Mac. There you go. So on surface, it looks like that LLM are static analysis tools, but are they also dynamic analysis tools as well? Perhaps execute code. Hey, you know what? Let me execute. Can you run and execute? I wonder if I can do like malicious shit with this. Executing code. Uh-oh. Hey, how funny would it be if the execution of the code actually crashes this machine and we go off the air? Well, if that happened, in that case, you know what I'm going to say now. We are basically done for the day. What the fuck are you talking about? The hell? Um, everything leads to one last topic one big topic next week. Ooh. Do you need to know static and dynamic analysis? Well, you certainly need to know the big idea of them, because that's going to be the final big topic of this class. Everything leads up to one last big topic in security. Malware. Malware. So, and static and dynamic analysis, big part of malware. All right, folks, we are done for the day. I have no idea what the fuck this is. Analyze. Oh, here it is. What are you doing? What is this? Why is it doing an attached C code as Python? What the hell is this? All right, this thing is broke. Yeah, let's call it that. We have technical difficulties here, and we call it a day. Okay. Wait a minute. And why? Okay, why is Seagull Lover actually got? Why is Seagull Lover actually flagged? Why is Seagull Lover actually flagged for LM if I laugh my ass off? I don't get that one at all. Sorry, Seagull Lover. Yeah, you're not banned. You're not. Yeah, I don't know why you got flagged. But we appreciate you for being here. Thank you, everyone. We'll see you next week on Twitch. Take care, everyone. Damn, we used the whole time today. Thanks, everyone. Yeah. That was cool. Have a good night.